Welcome to Math with Mrs. Bibb. Today I'm going to do some review and some notes because there may be some new skills that you have not seen before for your Algebra II Honors summer work assignment. The first thing I want us to do is to sketch the graph of each linear inequality on your own paper. Use Desmos to graph it for you, and then this video, it says please watch the video attached to the assignment in Google Classroom to help. And this is the video that you're about to watch. I am going to pull up Desmos. So this is what you should pull up on your screen when you're doing your assignment. And you should type in each question. So I'm about to do that. I can make this smaller. Oops. Okay, hold on. Take me a second to navigate that. Maybe I click away from it. There we go. Okay. Okay, I'm going to type in exactly what it says. Y is greater than or equal to 8 divided by 5. Click beside of it. X minus 3. Now, earlier, I hope you saw that I actually picked up the screen where the graph is at, and I drug that screen away, and so that's why you only see just red. If you hit the home button, then that takes me to where I want to be. Now, before I draw this on my paper, I am going to highlight a couple of points. I don't think I want to use that one. What's this one? I'm going to find a good one that's actually on the graph, but it may not happen. It's probably up here. Hold on. Down a little bit further. Okay, here we go. This one, and then should be somewhere through here. Tracing along that graph. Oh, it's fine. We'll just pick one. We'll just do this one. So I am going to graph that on my coordinate plane. I'll draw that coordinate plane first. My graph is going to be tiny because I've got Desmos open below there. Well, that's bad. Let me undo that. Okay. Now I'm going to plot the point 0, -3, 0, 1, 2, 3. You're welcome to use graph paper if you have it. And then I'm going to plot the point 1.8750. So that means 1, 2. So I'm going to go almost to 2. Then I can see that this is a solid line because of that greater than or equal to. So I'm going to draw a solid line between those 2 points. And then I'm going to shade above that line just as indicated in the picture. So make sure you have shading when you are doing your assignment. Make sure you write down the problem, then draw your graph. Use Desmos to draw that graph for you, but draw your graph on your paper and make sure you have shading. Now I did actually shade outside the lines. Whoops. So let me go back and shade that. Try to be better at doing that. Okay, there we go. I have graphed number 1. Now let's graph number 2. Okay, I just exit out. You can also backspace. I'm going to type in 6x We do not have to manipulate this equation in any way. You can just type it in as it looks. I'm going to do less than. I'll change this problem. I'll scribble it out in just a minute. Less than -5. Okay, and let me see. I'll make this less than just because I wanted it to be a little bit different, and it was not different, and here's why. Here's why the shading was not below the line. The y has a negative coefficient, so if you were to solve for y and divide both sides by -5, you would have to flip that inequality and make it greater than, which then the shading would be above, which is perfectly fine what I have. I am going to find me 2 ordered pairs on that graph, and then I will draw it on my paper. Okay, hold on. I'm going to use 0, 1. If I want to use that one or not. I will. I'll just use that one. Okay, now let's draw the graph. Here's my coordinate plane. I'll make it just a little bit bigger than the last one. And then I will plot 0, 1. And then I will plot -0.83, which means it's almost at -1. Put a dot there. Draw a dotted line between the points. And then I will shade again above my line. So if you have a highlighter, if you have a colored pencil, do that shading above the line. And really what we should do, and I'm going to go back and do this just so you can see, we really should shade in the area, the complete area of our graph. So I'll go back and do my shading. So this is my coordinate plane, a piece of it anyway. It's okay if you shade outside that coordinate plane. And then you should make sure that your shading is within your entire coordinate plane. So now mine is. I'll go back and do the same up here. So I got to add some shading. And I went outside of it a little bit, and that's okay. So now what this tells me, and we'll see in just one moment, is all the ordered pairs that are in this area are a solution to this inequality. And all the ordered pairs that are in this shaded region or area are a solution to this inequality. Now, any ordered pair on this line is a solution because it's equal to. Any ordered pair on this line is not a solution because it's not equal to. So that's the difference between those two. Now let's go on to the next example. For this next problem, if you will write down number 3 and then just write that list of ordered pairs. -1, 5. B. -2, -7. C. 0, 4. D. 1, 3. E. 1, -8. F. 0, 0. Oh, and we do not have to draw the coordinate plane. Oops. Let's just get Desmos up here. Okay. And let's graph X. X. just a second, hold on. X plus 2y is less than 6. Okay. Now, let's look at these ordered pairs. And you can zoom in if you want. There we go. -1, +5. As high as that goes is 3.5. So you can tell that at -1, +5, that would be, get my pointer, that would be here. So -1, +5 is not a solution for that inequality. I'm going to attempt to redo this audio for this video. I'm going to try to follow along and see, because I hope that it will also go back. There we go. So I think I'm plotting -2, -7 here. I have to try to remember. And so I'm showing you that -2, -7 was a solution in that inequality. Now I'm moving around the graph so that I can test to see if 0, 4 is a solution to that inequality. And I'm showing you that 0, 4 does not fall in the shaded region, so it is not a solution to that inequality. So I'm going to write no over there beside of 0, 4. Next, I'll look at 1, 3. 1, 3, and it is also not in the shaded region, so that means no, 1, 3 is not a solution. Then I will do 1, -8. I'm going to move that graph around, I'm sure. Try to show you that 1, -8 is not a solution. Go back to the origin. Go right 1 and down 8. I don't think I could get it to go all the way down to where you could see right 1 and then down to 8. And so 1, -8 is not is a solution, sorry. It is in the shaded region. And then 0, 0, you can see there on the screen. It is in the shaded region, so yes, it is a solution. Now to add audio back to this slide here, it asks you to solve each system by graphing. So you're going to use Desmos to graph. You do not have to isolate any variables like in other calculators that you have to have y by itself. You do not have to do that. You can just type it in the way it is written. And I'm telling you here that I want you to write the solution to a system, so make sure you have this on your paper, is where the graph crosses the x-axis or touches. Nope, and that's wrong. I wasn't sure how to delete that without deleting the writing too, so I was saying that incorrectly. It's where the graphs intersect. You're going to have two lines in this circumstance, and where they intersect, that ordered pair is the solution. If they do not intersect, then the answer is no solution. And if the graphs are the same, when you type in both equations, if they're the same graph, then that's when the answer would be infinitely many solutions. So that's what I'm about to write there, is infinitely many solutions. In Algebra 2, you will graph not just lines, these are all lines here, linear functions, but when you are in Algebra 2, you actually graph quadratics with lines. And I'm pulling up Desmos here so that we can type these into Desmos. When you do these, just make sure to write number 4 on your paper, just write down what you're going to type in, and then you'll write the solution that I'm going to come up with here. And hopefully you can see, and I don't think it showed, oh yeah, you can. If you watch the buttons, you can see which buttons I press to get those things. But you just type it in just the way it looks. The negative sign is the subtraction symbol. There's no separate negative sign here. The calculators in my classroom actually have a negative sign. So there's a difference between a negative and a subtraction there. And you can see the red and the blue line intersect. And if you click on where they intersect, it tells you the solution, -3, 1. So that's what we'll write there. And then that's the answer to number 4. And then next I'm going to get rid of what I have written, what I've typed in to Desmos. I'm just going to hit the X there. And I'm trying to do that, but it's hard to do that when you're writing with a pen. And then I'm going to type in number 5. Just going to type it in exactly the way it looks. Please write number 5 on your paper, and then type that into Desmos. Or when you're doing these actual problems, write the problems on your paper, and then type into Desmos to come up with the solution. There's no work other than writing the problem that needs to be shown. So those two lines, the green and the purple, intersect there. It looks like -4, -2. That's solution to number 5, -4, -2. And then I'll work on getting rid of, I'll put boxes around my answers. I like to have my answer stand out from the problem, so I put boxes around it. And then I will X out number 5's problems and type in number 6. Takes me a minute to navigate that. So I'm typing in number 6 there. Y minus x plus 3 equals 0. -8 equals -2y minus 5x. The solution is 2, -1. That's what's wonderful about Desmos, and you can use Desmos on the SAT. It is easy to use, and it tells you the answers if you know what to look for. Then I'm going to type in number 7. -2y minus 3x equals -6, typing that in. And be careful, always look back to make sure you've got it typed in correctly. And then 4y equals x minus 16. Then the solution looks like 4, -3. So the solution to number 7 is 4, -3. Okay, on to the next one. Okay, I was editing my video so I could get the sound back, and I deleted accidentally the next slide, so I'm trying to get YouTube to play here so that I can do the next slide with you, because it's no good when it deletes. So at least it was there on YouTube for me to pull up and play. I'm finishing that last slide again there, and the next one will be up here in just 1 second. So I apologize for the delay, but I couldn't seem to find it. So here's our next problems. We're solving systems by using substitution, and you do need to show work for these. And here on the right, I am going to be writing down the steps for substitution, so I'll read them to you as I start to write them. So here we go. It says substitution. Step 1, solve for a variable. So you pick a variable and solve for it. Step 2, substitute the expression from step 1 into the other equation. Step 3, solve. You're going to solve that equation. Step 4, substitute the answer or the solution from step 3 into step 1. And let's see, and you find the other solution, which makes your ordered pair. Okay, so I'm telling you there that that's my answer is going to be an ordered pair, my x value and my y value. And then for number 8, I know I solved for one of those variables. Can't remember which one. So I'm just talking about the coefficients. I think I solved for y on the top because I wanted to not have two fractions, because when you subtract 7x, you'd have 3y equals negative 12 and divide by 3, then you'll only have one fraction. So I believe that's what I do. And I show the work right here below there. So number 8, I'm rewriting the problem. And then I subtract 7x from both sides. 3y is going to equal negative 7x minus 12, and then I divide everything by 3. So y is going to equal negative 7/3 x minus 4. And then I'm going to take that expression, I highlighted, I think blue, I can't remember. So I take that expression and substitute it into the other y on the other equation. So I use the top to isolate for step 1, and so now I'm using the bottom one to substitute for step 2. So 2x plus 3 times negative 7/3 x minus 4 equals 3. Then I distribute, so 2x, 3 times negative 7/3 is negative 21/3, which will give you negative 7x. And then 3 times negative 4 is negative 12 equals 3. Then I combine like terms. So 2x minus 5x is negative 7x. 2x minus 7x is negative 5x. Then I added 12 to the other side. So negative 5x equals 15. Divide by negative 5, x will equal negative 3. And I put that up there in that top spot beside where x goes. And then I'm going to take this x equals negative 3, and I'm going to substitute it into x for the one we isolated by itself. So we're going to have y equals, I'm writing it right there beside the blue highlight, y equals negative 7/3 times negative 3 minus 4. And then negative 7/3 times negative 3 is positive 21/3. 21 divided by 3 is 7, and 7 minus 4 is 3. So that's where the answer negative 3 came from. And now for number 9, I'm going to move on to that one. For number 9, I decided to get x alone. I had two coefficients that were 1. Well, actually, no. I had one coefficient beside of the top y that was negative 1, and then I had a coefficient on the bottom that was positive 1. So I decided to get the x by itself from the second equation. So you'll see in just a moment I subtract 2y from both sides to get my x alone. And I don't know how long it's going to take me to get there. There we go. So I'm getting that alone. I'm going to subtract 2y from both sides. So x is going to equal negative 2y minus 8. Then I'll highlight that blue, and I'll show you that I'm going to put it into that top equation, 3 where it says 3x, I'm going to put 3 times negative 2y minus 8. So 3 times the quantity negative 2y minus 8 minus y equals negative 3. Then I distribute. 3 times negative 2y is negative 6y. 3 times negative 8 is negative 24. Minus y equals negative 3. Then combine like terms. Negative 6y and negative 1y is negative 7y. Minus 24 equals negative 3. Then I'll add 24 to the other side. So negative 7y equals 21. Divide by negative 7, y will equal negative 3. Then I should go up there and put an ordered pair, and I did, and I'll put negative 3 on the right-hand side of the comma. And then I'll substitute that negative 3 back into where I got my expression alone. So x equals negative 2 times negative 3 minus 8. So x equals 6 minus 8. So x equals negative 2. So my answer for number 9 is negative 2, negative 3. And then I do number 10 in the middle. And I believe for number 10, if I remember, I solve for the y on the top. So I get that y on the top by itself. Yes. So I'm going to subtract 2x to achieve that. So y will equal negative 2x plus 4. And then I will highlight that blue, and I'm going to substitute it into the bottom one. X plus 2 times the quantity negative 2x plus 4 equals negative 4. And then I'm going to distribute, so x minus 4x plus 8 equals negative 4. Then combine like terms. X minus 4x is negative 3x. Subtract 8. Negative 3x is going to equal negative 12. Divide by negative 3. So x is going to equal positive 4. And that will be what I'll put to the left of the comma. So 4 is my x solution. And now I'm going to substitute 4 into that expression right there. So y equals negative 2 times 4 plus 4. So y equals negative 8 plus 4. And so y will equal negative 4. So 4, negative 4 is the solution there. I think that's all. Okay, so we're going to solve by using elimination. I don't remember how long it takes me to start writing here. Here we go. So on the bottom right-hand corner, it says elimination, and then step 1. Not sure what I'm writing next. I don't remember. Number 1. Get one variable to have the same coefficients, the same but opposite coefficients, and you have to do that by comparing the coefficients and finding their least common multiple. And then step 2 you add, and step 3 you solve, and step 4 you substitute. So if you'll write that down, those are your steps you're going to use. And for number 11, I believe I decided to get the x, 3x and 1x. I believe I decided to get those coefficients the same but opposite. And you'll see me in just a moment write the coefficients above there, 3 and 1. And I'll write out some multiples of 3 and write out multiples of 1. So 3, 6, 9, 12, multiples of 3, 1, 2, 3, 4, multiples of 1. And their least common multiple is 3. So you want to multiply both of those by a number that will either keep it 3 or turn it into 3. So the top one will multiply by positive 1, the The bottom will multiply by positive 3. The next question I always ask is, are these two coefficients the opposite? Is one a positive and one a negative? And they are not, so that means you've got to pick one of those two numbers that I was just highlighting and make it negative, and I chose the top one. I made that negative 1, so I'm going to distribute negative 1 to all those numbers on the top. Negative 3x minus 2y equals positive 6, and then I'm going to distribute 3 and get 3x minus 12y equals negative 48. So that was step 1. Now I'm going to add them together. That's what step 2 says. I'm going to add those two new equations together. Negative 3x plus 3x, that cancels out. It's eliminated. Negative 2y plus negative 12y is negative 14y. And then 6 plus negative 48 is negative 42. And then you solve. That's what step 3 is. Divide both sides by negative 14. So y is going to equal positive 3. So that's elimination. So you solve, and now for elimination you have to substitute. I have to take that value of 3 and put it somewhere in one of those equations. So I'm going to substitute 3 into the bottom one, into that 4y. So x minus 4 times 3 equals negative 16. So x minus 12 equals negative 16. Add 12 to both sides. X will equal negative 4. So I'm finished with that one. Number 12 is much easier because if you notice, you already have a coefficient that's the same. The y both have a 2, and one's a positive and one's a negative. So you can immediately go straight to step 2 and add those two equations together. You can only do that when those two coefficients are the same but opposite. So just like the other one, number 11, students will just add those together, and that doesn't achieve the same results that we'll get in just a moment. 3x plus 5x is 8x. Negative 2y plus 2y, eliminated, equals 8 plus 8 is 16. So divide both sides by 8, that's step 3, x equals 2. And then I'm going to substitute 2 back into one of those equations. I think I did the top one, but I don't remember. Yep. So 3 times 2 minus 2y equals 8. So 6 minus 2y equals 8. Subtract 6 from both sides. Negative 2y equals 2. And divide by negative 2, y will equal negative 1. So the solution to that one. Okay, so for these two problems, all I want you to do is to define the variables, write the system of equations, and do not solve. And you don't have to write the problem on your paper. All you have to do is do what this says, define the variables. How you do that is go to the question. Number 13, there's a question mark in that problem. There's 3 periods and a question mark. The question will help you define your variables, and we're going to use x and y when we define our variables. And then I'm going to highlight for us the system, the sentences that we use to write our system. So there's number 13. I'm highlighting what is the cost of 1 rose bush and the cost of 1 geranium. So that will give me what my x and my y are going to stand for. And then for 14, how many students can a van carry? How many students can a bus carry? That will give me my x and my y. When I do these, the thing that comes first, the object that comes first, is what I say x is. X is the cost of 1 rose bush. And then y is going to be the cost of 1 geranium for number 13. And I think I finished number 13 before I move on to number 14. So the next thing I'm going to do after I write y is the cost of 1 geranium, the next thing I do is highlight in 2 different colors 2 sentences for number 13, because those are my 2 equations. So you'll see Wilbur spent $98 on 10 rose bushes and 2 geraniums. I'll highlight those one color, that sentence. And then I'll highlight Jill spent $178 on 11 rose bushes and 10 geraniums, another color. I don't know how long it will take me because I don't remember what I was saying in the meantime. There we go. So in blue, I do that first sentence for what Wilbur spent. And then in, I don't remember what color, red maybe. Oh, okay, I wrote equals. So he spent $98, a total of 98. Total you add, what do you add? 10x, 10 times the cost of one rose bush, so 10x, plus 2y, 2 times the cost of one geranium. That total is 98. So that was the blue equation. Now the next one that I highlight is the Jill spent $178 on 11 rose bushes and 10 geraniums. So I'm going to highlight that in red. And so he spent a total of $178. Total means add, and it equals 178. So I'll probably put, I don't know which one I put first, add, and then it equals 178. Well, what equals 178? 11 times x, 11 rose bushes, plus 10 times y, 10 geraniums. And that's the answers. That's all I need for questions like number 13. That's it. Now we'll go on to number 14. For number 14, the first thing I'm going to do is I am going to define those variables. My x is going to be that first question, the number of students in a van. I don't use that fancy. How many students can a van carry? Number of students in a van. That's sufficient there. And then y is going to be the number of students in a bus. So that's my x and my y. And now I'm going to highlight high school A. That's my first sentence. I'll highlight that in blue. And then I think I write the equation, but I don't remember. So high school A rented and filled 3 vans and 6 buses with 198 students. So 3 vans, 3x, plus 6 buses, 6y, total of 198. So you add them together and it equals 198. And then in red, I'll highlight high school B rented and filled 9 vans and 13 buses with 469 students. So a total of 469. You'll see in just a moment a total. So you add together and get 469. What do you add together? You add together 9x with 13y to give you a total of 469. So add to get a total, so equals. And that's the solution to 14. That's it. That's all you have to do. Now for my next one, I'm going to ignore the fraction first because there's something special I have to do with that. I want to think about 16 and 4. Can I rewrite 16 with a base of 4? Yes. I could also rewrite both of them with a base of 2, but I'm going to rewrite 16 with a base of 4 first. So I'm going to have 4 to the second power to the negative n minus 2 is going to equal 1/4 to the n power. Now, I cannot do step 2 yet. My exponents are not equal yet because my bases really aren't the same yet. I have 1/4. How can I rewrite 1/4 with a base of 4? So hopefully you remember those exponent rules that says 4 to the negative 1 is 1/4. So a negative exponent means you have a fraction. And so 4 to the negative 1 is 1/4. And now my bases will be the same. And I can write my equation. My exponents are equal. 2 times negative n minus 2 is going to equal negative 1 times n. So distribute on the left. Negative 2n minus 4 equals negative n. Add 2n to both sides. So negative 4 equals n. That's the answer to number 16. Number 17, my bases are the same. 9 and 9 are the same. So I know negative 2k equals negative 2k minus 3. I'm going to add 2k to both sides. 0 equals negative 3. That's weird. That's not true. So this one is no solution. When your variable is eliminated, you're going to have one of two answers. If you're left with a true statement, then your answer is infinitely many solutions, which means no matter what you select, what number you select, that number will satisfy that equation. If you're left with a false statement, then that answer is no solution. No matter what number you select to put in for the variable, you will create a false statement. It won't work. Okay, now the next one is strange, but I can rewrite 243 with a base of 3, but I don't not remember what that was. So let's just go through and see. 3 to the first power is 3. 3 to the second is 9, and please write this down on your paper. 3 to the third is 27. 3 to the fourth is 81. And 3 to the fifth is 243. So I'm going to rewrite that as 3 to the fifth divided by 3 to the negative 2n minus 2 is going to equal 3 to the third. Now we've got to think about exponent rules. What do I do when I'm dividing bases that are the same? What do I do to the exponents? Well, hopefully you remember you subtract. So I would have 3 to the 5 minus, in parentheses, negative 2n minus 2 would equal 3 to the third power. So when you're dividing, you subtract. When you're multiplying, you add. Don't forget that. So now my bases are the same. My exponents are equal. So I've got this equation to solve. 5 minus the quantity negative 2n minus 2 equals 3. I'm going to distribute that negative sign. So 5 plus 2n plus 2 equals 3. I'm going to combine like terms. 2n plus 7 equals 3. Subtract 7. 2n equals negative 4. Divide by 2. N equals negative 2. That's my answer to number 18. Number 19. Now I have bases that are the same and I'm multiplying. So what do I do to exponents when I have the same base and I'm multiplying? Well, hopefully you knew to add. 4 to the negative 3k plus k equals, Can I rewrite 64 with a base of 4? Yes. 4 to the first power is 4. 4 to the second power is 16. 4 to the third power is 64. So equals 4 to the third. And now my bases are the same, so my exponents are equal. Negative 3k plus k equals 3. So negative 2k equals 3. Divide by negative 2. K will equal negative 3 over 2. Please no decimals. And please no mixed numbers. Leave it as an improper fraction. Now, to factor completely using the area model. The area model is just a box. So for each of these, I want you to write down the problem, and then I want you to draw yourself a box. In that box, n squared goes in the first box, b squared goes in the first box, and negative 21 goes in the second box, and negative 21 goes in the second box. Let's do that now. So n squared negative 21, b squared negative 21. Now, our answer is going to be on the outside. Our factorization is going to be on the outside. Now, I look at these like Punnett squares. That's what they look like to me. What do I multiply to get n squared? Because we're really multiplying. That's what this is here. I'm not going to put that x there. I'm not going to leave it. I'm going to undo that because I don't want to leave an x there. But we're really multiplying. Okay, so to get n squared, that's n times n. Now I need to multiply to get negative 21. Well, there's several ways I can multiply to get negative 21. Well, to multiply to get positive 21 is 1 times 21 and 3 times 7. But to get negative 21, then I need one of them to be negative, so I'm going to put negative 7 and positive 3 and see if that will work. Now, my goal is, when I multiply, I want these two to add up to give me positive 4. I want these two to add up to give me negative 4. So let's see if my first guess was correct. Negative 7 times n is negative 7n. And n times positive 3 is positive 3n. When I add negative 7n and positive 3n, do I get positive 4n? No, I do not. So I'm going to make this a positive 7, and I'm going to erase well, I thought I was going to erase. Maybe it won't let me because I'm going to have to scribble it out. And make that a negative 3. So this would be positive 7n, this would be negative 3n. 7n minus 3n is positive 4n. So I have my answer. I want you to remember, because I'm going to ask it often, the definition for factor is to rewrite a polynomial as a product of polynomials. So, as I said before, my answer's in the green. My product is two binomials, n plus 7 and n minus 3. Whoops, and I wrote 7. Did you see that? N minus 3. So n plus 7 times n minus 3. I just factored n squared plus 4n minus 21. Now I want to factor the next one. What can I multiply to get v squared? V times v. And to get negative 21, again, we said 1 times 21 and 3 times 7. So I'm going to put minus 7 here and plus 3 here. Negative 7 times v is negative 7v. V times positive 3 is positive 3v. If I add the blue, do I get negative 4v? Yes, you do. So my answer is the product of v minus 7 times v plus 3. And that's my answer to number 21. We'll go on and do the same thing for the next one. Okay, draw an area model for both of these. In the first box, you're going to put the first variable. In the second box, you're going to put the constant. And our answer will be along the top and the side, the top and the side. And these two have to add up to give me this. And these two have to add up to give me this. Okay, so n squared goes here, a squared goes here, negative 32 goes here, positive 45 goes here. And then factors of 32, 1 times 32, 2 times 16, 4 times 8. And see, when I look at this, I believe these are the two that are going to work, but I got to get negative. So anyway, let's do the n first. N times n is n squared. N times n is n squared. N times n is n squared. What times what gives me a squared? A times a gives me a squared. Okay, and now I'm going to do positive 8 and negative 4 and see if that works. Positive 8 and negative 4. Does that work? Positive 8 times n is 8n. Positive n times negative 4 is negative 4n. Do 8n and negative 4n add together to give me negative 4n? And the answer is no. So then that means I'm going to make this, and I'm so sorry I can't erase. We'll make this negative 8 and make that positive 4. So negative 8 times n is now negative 8n. N times positive 4 is positive 4n. And negative 8n plus 4n is that negative 4n. Yes, it is. So now I have my factorization. It's the product of n minus 8 times n plus 4. That's my answer to number 22. Number 23. Multiply to give me 45. 1 times 45, 3 times 15, 5 times 9. I think these are going to be the ones that work. So if I put positive 5 and positive 9, this gives me positive 5a and positive 9a. Well, 9 plus 5 is not negative 14. So this is going to have to be a negative 5 and a negative 9, because negative 5 times negative 9 is still, let me get my highlighter, my pointer, negative 5 times negative 9 is still positive 45. And then negative 5 times a is negative 5a, a times negative 9 is negative 9a, and those two do add up to give me negative 14a. So my answer is the product of a minus 5 times a minus 9. So this is the kind of work I expect to see on your paper. You should have the boxes drawn. You should have factors written down. You should have the original problem written down. And then you should end up with a product of two binomials. Okay, I've got 2 more to do and then I'm done. Okay, so draw 2 boxes, 2 area models. And I'll just remind you, in the first box is that first variable. In the last box is that last constant in the middle. These two should multiply to give me, or should add to give me this. These two should add to give me this. And our final answer will be on the top and the side. On the top and, whoa, this side. Sorry, I keep hitting my controls there. I don't think you can see them, but I keep hitting them. Okay, there we go. Top and the side. Okay, and then my factors. Let's think about factors of 32. 1 times 32, 2 times 16, 4 times 8. And factors of 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9. Okay, so in this first spot is going to go x squared for both of these. And what can I multiply to get x squared? X times x. X times x. Okay, and then I'm going to do 4 and 8. Positive 4 and positive 8. Those controls are too close to the side. There we go. Positive 8. Okay, and so 4 times x is 4x. Oh, I forgot. I'll get that in a second. X times 8 is 8x, and 4 times 8 is 32. I forgot to put that there. Forgot to put 36 here. Okay, so 8x plus 4x, is that negative 12x? No, so I need to make both of these a negative, because that will give me a negative 4 times a negative 8 will give me a positive 32. Then negative 4 times x is negative 4x. Negative x times negative 8 will give me negative 8x. And negative 4x plus negative 8x is negative 12x. So it's a product of x minus 4 times x minus 8. That's what works. And then the last one, I'm going to do positive 4 and positive 9, because I know 4 plus 9 is 13. Positive 4 times x is 4x. X times positive 9 is 9x. 4 times 9 is 36, so that's all correct. And then 9x plus 4x does give me 13x. So this is my product, x plus 4 times x plus 9. A product of x plus 4 and x plus 9. And that's my answer. So I hope that you'll be able to factor the area model easily. If you need help doing that, if you need more examples, let me know. I'm happy to give you more examples. Have a wonderful day.